Hello everyone, my name is Kiana White and today I'll be doing Lab 5, Choose Your Own Adventure. For today's lab, I'll be discussing Newton's second law to describe Newton's first law. So we're going to discuss we're going to discuss a ball that moves at a constant velocity. And the topics that are going to be discussed are Newton's second law to confirm Newton's first law. A ball at motion stays at motion unless acted on by a force. So the ping pong ball is about 0.01 kilograms. The initial time is 0. The final time is 2.1 seconds. The initial position is 0. The final position is 0.905 meters. We're going to use this information to calculate the average velocity, which is change in position over change in time, and get an average velocity of 0.104 meters per second, or in vector form. We can also calculate the center of mass with the information that we have found, and that is simply just the position times the mass, which is going to be 0.01, which then gives us 3.436 times 10 to the negative 5, and then divide that by the total mass, which this in turn is correct. I think I just forgot a 0. Yes, so then this should be 0.00344, and that is the center of mass. We can then continue with the formulas. We have Newton's second law. Vf is equal to Vi plus the F net over m times delta t. V average as change in position over change in time. Then we have the position update, which is position final, equals position initial plus Vf times delta t. And we know that F net is 0 because there are no forces acting on the ball besides gravity and contact, which in turn do cancel out. And so if we're looking at the table and the ball is here, we have gravity pointing down and the contact force, or the normal force, pointing up. There are no net interactions, which equals no forces, which therefore in turn equals constant velocity. Here we have a graph of the observed versus the predicted. So this is the predicted values based on the GlowScript code, and these are the observed values based on the tracker video. They are pretty similar. One's just a little broader. Here is the points and tracker. Here is an example in GlowScript. And here is the line of code. I updated the mass, which is in kilograms, the initial position, final position, initial velocity. I updated the timestamp. Instead of 0.01, 0.33, with the clock stamps at 0. And since my final time was 2.1 seconds, as long as t is less than 2.1 seconds, everything will be calculated. I then updated the net forces, which were 0, and here's the position, or the Newton's second law equation, and the momentum principle, and the position. So this summarizes that Newton's second law was used to confirm Newton's first law. An object will stay in motion unless acted on by an opposing force. Thank you.